Good morning, fellow teachers and students. Good morning, class. Okay, thank you. You may sit down. Okay, quickly to recap on what we went through in our last lesson. Joe, can you tell us what is a scalar quantity?
A scalar quantity is one that has size but doesn't include direction.
Okay, good. A scalar is a quantity that has only the size but no direction. Good. Okay, what is a vector? Josh, you tell us a vector quantity.
A vector quantity is quantity that has size and also direction.
Okay, very good. So if you look at these two, our scalar is a quantity that has only the magnitude or simply the size and no direction. So simply we have to look at the vectors. Vectors are those quantities that have both size and direction, and we have looked at some examples of vectors yesterday. For example, if it is 1 plus 1, let's say you are trying to take a mesh. One stone plus another stone will give you 2. Okay, that is a scalar. Okay, it is talking about the mass of those stones. But if you look at other quantities like velocity and displacement, acceleration, those are examples of vectors, meaning that they have size and direction. And also force is a vector quantity. Now in this lesson we'll be looking at how we can combine vectors. Now, vectors, when they are parallel, you can simply either add or subtract those vectors. For example, if you are given right, 2 newtons, which is moving in that direction, okay, plus another, let's say, 4 newtons, which is moving opposite that. Okay, the resultant of those will be? Okay, good. It will be 2 newtons to the left, also in that direction. So that is how you can combine vectors. Now let's have a look at if these vectors were given, let's say at 90 degrees. Okay, those two vectors are acting at 90 degrees. Okay, one example given is, we have to consider this one. Alright, you find that an aeroplane is flying east at 120 kilometers per hour. Right, velocity is also a vector, and which encounters a strong wind at 90 kilometers per hour blowing to the north. Right, to find the resultant, we have to draw a scale and use trigonometry involving a triangle. Now, if we were to use a scale, let's say we were to draw that into scale or using a scale. Right, it will be something like this. Okay, this is 1. Okay, the plane is flying towards east. Right, if you have to use this as a scale, each one of these will be about 20 newtons. Okay, rather not 20 newtons, but 20 meters or kilometers per hour. So it'll be 20 plus another 20 kilometers per hour, plus 20, plus 20, 20. That gives you 120 kilometers per hour to the east. Now, if you consider another one which is blowing at Okay, I'll quickly clean this one. It is about 20. Okay, that is 20, 20, 20. Then you have another 20 plus 10. So it is about 90 kilometers to the north. This, then you can throw a scale and also use that as a scale. Right, if you have to use a scale correctly, you'll find that this one will be almost equal to the calculation that you make. If you were to do that mathematically, you'll find that this will be almost equal to the scale that you use. So you can also use a scale to represent these vectors. I quickly have this information done. I will show you the example of this, and then I will give you these activities to complete. Pilot teachers, you can also tell your the pilot students to quickly go through and then have the example done. Right, the explanation of that example will come after you have taken down or you have the notes. You finish copying these notes? Yes or no? Okay, we'll move on to the... You have this information as well. You finish. Finish, sir. Okay, we will now go through based on the example, right, you watch carefully and listen as I go through the explanation. After that, I will give you some activity that you can complete, then we'll have a look at that. All right, firstly, okay, vectors had right angles, right? You know that when these vectors are parallel, you can simply add or subtract. But when they at 90 degrees or at certain angles from each other, you will find that you can use the cosine rule to calculate these forces, or you can use the Pythagoras theorem to calculate the resultant of those forces that are acting. And also, if there are many forces acting at a certain point, you can also use or find the resultant in what direction this force is moving. All right, for the first example shown, right, you have something which is a plane which is moving towards the east, and then you have the wind speed which is about 120 kilometers per hour. All right, there is another wind, or let's say the force of the wind is coming towards it's moving towards the north, and you saw that the magnitude or the size of the wind was 90 kilometers per hour. Now, you have to look at that resultant. Basically, this one is not moving straight. The resultant is because of this effect of this speed that is coming or moving towards the north, and the one that is moving towards the east is now causing it to move slightly upwards. So that is the resultant. And we can also calculate at what angle this resultant is acting. Okay, if you have to look at this, how do we indicate that resultant? Now, simply the resultant, if you have to look at that, is about 120 kilometers per hour from the east. And then you have another one which is, you can have it as that, or simply you can have the resultant as it is. In here you will find that the resultant are always in the same direction. Okay, this is a resultant. If you decide to draw it that way, or if you decide to have it this way, the resultant is still facing in that direction. Now, if you want to calculate this, you will use the Pythagoras theorem, and the resultant will be 150 newtons in the direction. We can simply say east at 36 degrees to the north, or it can be 150 newtons in the direction of north, and this angle in which you have to calculate, it will be about 53 degrees. So it is about 150 in the direction north, 53 degrees of east. Right, you can go through those information and then do that later on. You can calculate and then write it down. Right, if you have to look up, I'll quickly go through and then show you something before you go on to that activity. All right, consider this example. Now, if somebody is applying a force of 40 newtons to pull this cart, now you will find that this will be moving towards, but then you find that he is applying 40 newtons at this angle. How do you calculate the force that is acting downwards and also the force that is moving. If this is the case, you will use this method to solve that into components. So the first one is force times cosine of this angle, which is 40 times (20) cos, or cosine of that 20. And if you have to calculate the force that is acting downwards, you can use 40 times sine 20. You can use that to calculate the components of the force that is acting downwards and also the force that is acting this way. Okay? In other words, this is somewhat like the resultant. Right, I'd like you to quickly go through. For this information here, you can do that later on. What I'd like you to do now is to quickly go through and then do these 3 examples or activity. Okay, that is the horizontal component and V is the vertical component. Okay. Let's see. You concentrate with the Okay, you finished the first one. Raise your hands. I'll come around and check your answers. Okay, if yours is correct, I'll tell you to go and explain how you got that answer. Okay, for the first one, whichever way you start, you will still find that the resultant will be in this. Okay, you've seen what you can do, and that is simply to join the arrows head to the tail. Finish. Okay, by now you should have finished question number 1 or activity 1. Okay, complete that. If you have diagram already done, quickly show that. If you don't know what to, raise your hand so that help will be coming. Okay, you start at any point. Just say which one. Okay, where do you want to start? Show me which one of these would you start from. A. Okay, this is A. Oh, sorry, this is assignment. Okay, this is A. Okay, where does B show you? B, where does it go? Okay, so you go this way. Just same as where it is. Where does C show? So it goes this way, okay? And where does D show? Okay, you complete. Finish? Okay, let's see which one of this point would you start from? Huh? A, okay, you start from A. Draw as where A is, just equals, and then you draw just that vector. Yeah, draw that. You draw exactly what is here. Okay. No. Just that straight line vector. A is showing that way, so you draw that direction. Okay, some of you not aware of what you can do for the first one. Right, if you want to, let's say you have this, okay, that is a stone, and then you have another force which is this way, another one pulling in that direction, you have another one pulling in that. How do you show that? Right, simply we have to bring this one over, maybe I'll have it here. Okay, if you want to start over here, we have it as this one. The next one, let's say we want to have this one. It is facing in that direction. And then you have another one which is coming that way. So it will be, where will be the resultant? Okay, resultant will be moving in that. Okay, now let's have a look at the. Now, if we want to start from this one, we move this way, and then this way. And finally, we take this one. Okay, you will find that the resultant is almost similar to this one. Okay, it is moving in that direction. All right, quickly have this. Okay, you started off with this. A, where is B? Okay, you start off with B. B, then A, and where is C? C will be moving in that.
Okay. So A is moving this way.
Mm-hmm.
And then D would go. Do I have to go A, B, C, and D? Or
You can go A, B, C, D, O, whichever, yeah. Or start from D and then you come back to A. Okay, let me see how you got the resultant. Okay, very good. The resultant will be this way. Okay, that is the resultant. Now, if you want to try another way, let's say you started off with A. This time you start off with D. D is there, huh? And then you go, this is C. And then B is in that direction. sorry, A is the, okay, the resultant would be pointing to A. Okay, you find it, it's also in the same, it's almost like going this way. Okay, you go for the first question. Okay. All right, do it quickly. I'll give you those two. Let me see where you. Okay, first one. Show. Where is it? A, B, C, D. Okay, resultant will be A, B, C, D. So it will be always moving towards. If we start from A, this is A. B will be this way. Then you have C. And then you have D. Resultant will be this way. Yeah. A. Okay, A is here. Goes over there. B, C, D. So it does not start from here, but from there to there. Okay. Let me see. Where is your resultant? Okay, you start from. Where did you start? Okay, D. D was going up that way. C. And then you have B, which is also there. A. So the resultant will be moving from the last to the next. Okay, not down this way, but yeah. Okay. For question number 2. Who has finished question number 2? Where is your question? Yeah, okay, that's correct. Let me see yours. Okay, correct. Yours, where is the resultant? Okay, resultant, if this is D, the resultant starts from where you started, so it will be moving towards the last head. Okay? Okay. Question number 2, quickly complete question number 2. Let me see yours. Come. A, where is A? A is moving towards head. B. Okay, A, D, okay, C, B, the resultant, okay, correct. Find that it's always moving there. Question 2, quickly complete question number 2. Okay. I'll give a few more minutes and then we'll go through the correction of the questions. Maybe we'll do question number 1 and question 2 only. Okay, for question 2, quickly complete question 2. For the last question, you can copy, but probably will consider that question as a homework. You can do that for homework, and then we'll have a look at that question in our next lesson. That is for activity number 3.
How do we get 2c cosine
Which one?
2c?
To see the two forces going to create zone. All right, you saw the resultant and then calculate and explain. You will use the
Angle. Yeah, how do we work out the angle?
angle. Right, if you have to put that carefully, you will find that, or correctly, you find that you will be using,
Cosine.
okay, not cosine, but 10 ratio to calculate it, okay? Because you see, there's another force coming down, and you find another force moving that way. So if you want to draw that, okay, you can, one coming, or let's say you started with this one moving that way, the resultant will be here. So you'll be using to calculate this angle here.
That angle.
Yeah. So it'll be opposite, which is
And adjacent.
over the adjacent. Yeah, which is 60. Or if you decide to have it as this one, let me say no, this one coming first, and then you have another one which is moving down that way. You still find that the resultant is also in that. Okay, you still find that the resultant is moving in that. So you are calculating this.
Calculating this same
Yeah,
angle.
yeah, yeah.
So this is the adjacent. Adjacent is the opposite. And this going down is 80. But it can't be the same answer.
Yeah, it cannot be the same. One will be more towards one direction. Okay, you saw from that example, you see 150 in the direction of east, 30 degrees north. And one of those would be 150 in the direction north, but towards east, okay? Okay, you go for the resultant. Calculate, show the errors. Okay, number 2, the resultant will be. Okay, we will now go through the correction of the those activities. Right, the first one I will ask Joseph. Joseph, you can comment to question number 1. Right, showing those the resultant of those vectors. Right, when Joseph is up, Diane, you get ready for question number 2A. Okay, clear this. Clear this. Okay, you can go on that side or this side. Make sure the camera can pick you. Go on that side. Thank you, Mike. Pass it, Mike, over.
find the resultant, it's just simple. You follow the arrows. First you go west, then you come down southeast, and then you go up. You go up northeast, and then you go up north. So from A to D, there is a resultant.
Okay, very good. So you should have a resultant which is almost looking something like this, right? The resultant will be there. That is when you have to start off with A. Same, this is A going that way, so A, and then you have B going downwards in that direction. So you have it that way, and C, you find that C is going upwards, and D is that way. So the resultant will be joining head to tail. The final resultant will be facing in the last. Or if you decide to have it another, let's say this time you are starting off with D. Okay, that is D, and then you go AC, that is C, and then B will be, A is, okay, anyway, A is just moving that way, so the resultant will be, okay, you will find that this is almost equal to this one. Okay, it is moving in that direction. Okay, very good. Okay, we'll have the second answer to question 2A. Okay, you use this part.
Like the first one, there can be two ways of drawing the resultant. You join them from head to tail, and then you get your resultant.
Okay, very good. That is the answer to question number 1. You can have it the two ways. Basically have this one downwards. All right, that is 80 newtons, and then you have 60, and the resultant will be that way. Or you have 60 or 80 newtons, 60 newtons first, and then 80 resultant. And this are always in the same direction. We'll have answer to question number 2. Okay, let's see who is. Maima, you do question number 2. Calculate the resultant of the forces. Okay, is that marked black one? Yeah. Okay, the last answer question. Who is going to do that? Simon, you do question number. Okay, Michelle, you haven't finished. You finish? Okay, you do the last question for C. Okay, 2C. You willing to question 2C? 2C. Question 2C. Yeah. Okay, let me see. How do you put it? Okay. Divided by constant C. Yeah. You can still do that.
To find a resultant, I used the Pythagoras theorem, the square root of 60 squared plus 80 squared, which is equals to 10,000. Square root of 10,000 is 100 newtons.
Okay, very good. So the resultant will be 100 newtons. Okay, the last one, we will have Rachel. Okay, Rachel, you took. Okay, she's doing the question for me.
I got my answer 36.9 degrees by using the formula tan equals opposite over adjacent. The opposite in this example is 60 over the adjacent is 80. And I got 0.75. And by using my calculator, I got 36.9 degrees.
Right, good. That is C. Okay, you will find that there are two angles in which you can calculate. All right, this is 36.9 if you have to, for this one. So it is about south 36.9, so east. Or if you decide to use this one, it will be about 53, or let's say east 53 of south. Okay, so these are your answers for question, or let's say for question number or activity number 2. Right, quickly, pilot students, you can simply go through, copy these answers, and then you check with those questions later on. Now, for the last one, maybe you can go through this question, or let's say activity number 3, and then complete that for homework, and then we'll have a look at that question in our next lesson. And finally, to summarize this lesson, vectors are quantities that have both size and direction, but when different vectors are starting from one point, you have to join that head to tails. And finally, you find that the resultant that you get from this joining of the head and also the tail will always face in one direction, and you will always come up with only one resultant. And for question number 1, you have looked at how you will calculate the resultant when forces are acting, or let's say only 2 pairs of force are acting at 90 degrees. And the answer that you got from was 1,000 newtons. Okay, good. That brings us to the end of our lesson. Okay, our keyword for today is simply combining the vectors. Right, may I ask you the question now? Good afternoon, pilot teachers and students. Good afternoon, class. All right, thank you. You may sit down.